I'm holding my phone right now. Go ahead, grab yours too. Now, flip it. Not just any flip, flip it around its middle axis, the one going through its thin edge. Did you see that? It twisted. It rotated in a way you didn't tell it to. Your phone just changed its mind mid-air. Why does that happen? Why does rotation around the middle axis seem to have a mind of its own? This phenomenon has a name, the intermediate axis theorem. Some people call it the tennis racket theorem because, well, tennis rackets do it too. Every rigid object has three principal axes of rotation, three invisible lines through its center where it spins most naturally. Two of these axes are stable. Spin something around them and it keeps spinning predictably. But the middle axis, the one with the intermediate moment of inertia, that one is unstable. What does intermediate mean? If you calculate the moments of inertia, basically how mass is distributed around each axis, you get three numbers. Let's call them I1, I2, and I3. The smallest is I1, the largest is I3, and right in the middle is I2. Let's test this. Take your smartphone. First, spin it around the long axis, the one from top to bottom. Toss it gently. It spins cleanly, right? Stable. Now try the short axis, the one going through the screen from side to side. Toss it. Still stable. But now, try the middle axis, the thin one going through the edge. Toss it with a spin. Watch closely. It doesn't just spin, it flips. It rotates around another axis entirely. Now grab a book. Same experiment. Spin it around the long axis, through the spine. Stable. But spin it around the middle axis, the one perpendicular to the cover, through the thickness. Toss it. So why does this happen? The answer lives in the relationship between angular momentum and rotational kinetic energy. When you toss your phone, its total angular momentum stays constant. That's a law of physics. This isn't just theory. In 1985, astronaut Vladimir Janibekov was in space working with a wing nut. He spun it, and it flipped, just like your phone. This became known as the Janibekov effect, or the tennis racket effect. Tennis players noticed it too. Flip a racket around its handle-to-head axis, and it stays put. Flip it around the middle axis, and it tumbles. Even satellites tumbling in orbit obey this theorem. The universe doesn't care what you're spinning. Can you control this? Yes and no. The instability is fundamental. You can't make the middle axis stable. But you can add spin around a stable axis to dominate the motion. This is how satellites stabilize. They spin around a stable axis on purpose. Gymnasts and divers use this too. If you want to try this at home, start with something soft like a small pillow or a deck of cards. The math behind this is surprisingly elegant. Euler's equations tell us that for rotation around the middle axis, any deviation grows. But you don't need to solve differential equations to see it. Just flip your phone. So, to recap, every object has three principal axes. Two are stable, one is not. The unstable one is the middle, the one with intermediate moment of inertia. Tiny wobbles grow into full flips. So next time you drop your phone, hopefully onto something soft, and it tumbles in that weird, unpredictable way, you'll know, it's not random. It's the intermediate axis theorem doing what it always does. Now go flip something, safely.